Yes, welcome to this video. This is the second video of unit number 2 of the course Partial Differential Equations Vector Calculus. In the first video, that is the last video, we have discussed the method of solving a homogeneous linear PDE with constant coefficients, and the right hand side function is 0. And we observed that the solution of such a PDE contains only complementary function z equal to CF. But in this video, we'll discuss the method of solving a homogeneous linear PDE with constant coefficients when the right hand side function is not 0 but some exponential function, that is a function of the form e power ax plus by, where a and b are some constants. Okay, so whenever the right hand side is not 0, then the complete solution will contain another part called the particular integral. It is the part of the solution corresponding to the right hand side function. So the general solution will be z equal to CF plus PA. So to get more clarity, let us discuss on the whiteboard. Yes. So in this video, we are going to discuss solving partial differential equations, PDEs of the form partial differential equations of the form some function of d and d dash operating on z giving e power ax plus by, where a and b are fixed constants. Where a and b are some constants. Okay. Now, so here right hand side is not 0 but exponential, e power 2x plus 3y, e power x minus y, like that. So the method involves 3 steps. Step 1, first write the auxiliary equation. Write the auxiliary equation. We'll call that as simply AE. That is auxiliary equation. Write the auxiliary equation simply by replacing d with m and d dash with 1 in the LHS operator f of d dash. F of m1 equal to 0. This is called the auxiliary equation. Okay. Solve and find the values of x. Solve and find the values of m. Find the values of m. Then write the complementary function. Then write the complementary function. This is complementary function denoted by CF. Already we have discussed in our first video. Okay. So the first part resembles that of the previous model. So the first part contains only complementary function, that is nothing to do with the right hand side. So whether the right hand side is 0 or e power x plus b by, complementary function will be same. And already you know the different cases of writing complementary function. When the roots are real and equal, the roots are real and distinct, like that. Okay. So follow the same procedure. Next, the second part contains particular integral. The particular integral, it is simply denoted by PI. So the particular integral is given by the formula PI equal to, but apply the inverse of this operator 1 by f of dt dash. Inverse of f of dt dash means 1 by f of dt dash. So this is to be applied on the right hand side function e power ax plus by. This is the structure of this particular integral. When we apply the inverse operator of f of dt dash, that is 1 by f of dt dash on the right hand function, what we will get? Okay. So the process is like this. First, what we'll do is simply note down the coefficient of x and coefficient of y. Coefficient of x means a, coefficient of y means b. So the process is put d equal to a and d dash equal to b. Put d equal to the coefficient of x, that is a, and d dash b in f of dt dash, and see what happens. So then what we'll get? We'll get 1 by f of a comma b into e power ax plus by. Okay. So you will, by replacing d with a, d dash with b, we will get 1 by f of ab of e power ax plus by. So we can stop second step, particular integral here itself, provided the denominator is not equal to 0. If the denominator is non-zero, for example, some 2 or some 27 or some minus 33 like that, then we can stop here. Step 2 is over, close. But there is no guarantee that f of AB is non-zero. Okay. So they'll continue. If f of AB is not equal to 0, then our particular integral will be simply what we'll do is, in place of f of d dash, we'll consider its partial derivative with respect to d. Simply treat d and d dash as two different variables. By ignoring d dash, that is by treating d dash as a constant, simply find the partial derivative of this f of d dash with respect to d and multiply outside with x. That means the formula will be like this. X into 1 by dou d of our f of d dash to be operated on e power ax plus by. Okay, x into 1 by the partial derivative of f of d dash with respect to d of e power x plus by. Again, same process. So in this, so for our convenience, we can write this as f suffix x. So for more clarity, the first order partial derivative of d dash with respect to d, we will denote that with f suffix s for our convenience only. Okay. First order partial derivative with respect to d. Okay. Now, or we can take fd also, no problem. Better to denote this fd. Then what we'll do is again we'll replace d with a, d dash with b. So put d equal to a and d dash equal to b. Then what we'll get? X into 1 by fd of a comma b of e power x plus b. In this first order partial derivative, we'll replace d with a and d dash with b. So this will be the answer provided the denominator is not equal to 0. Okay, if the denominator not equal to 0, we can stop here. But by chance, if this denominator also becomes 0, if this fd of AB is also 0, sorry. Okay, then our particular integral is multiply with one more x square and consider one more partial derivative, dou square by dou d square of f of d dash, and then apply on e power x plus b. Okay, so x square into 1 by dou square dou d square. For our convenience, let us denote this with f of d square of d comma d dash. D square means second derivative with respect to d. Okay, we will use this notation for our convenience. Again, put d equal to a, d dash equal to b. We are following the same substitution again. Then we will get x square into 1 by f of d square of d comma d dash. Sorry, d plus d with a. So this is a and this is b. Okay, into e power x plus b. This will be the answer provided the denominator is not equal to 0. So continue this until we get non-zero denominator. So continue till we get a non-zero denominator. This is the process. Second step. So the particular integral is given by 1 by f of d dash of e power x plus by. Put d equal to a, d dash equal to b. If the denominator is non-zero, well and good. This will be the answer. But unfortunately, the denominator becomes 0. Then in place of f of d dash, write its first order partial with respect to d and then multiply outside with x. For our convenience, we are denoting first derivative of f with respect to d with f suffix d for our convenience. Now put d equal to a, d dash equal to b again in that first derivative. That will be the answer provided the denominator is non-zero. But again, if denominator becomes 0, then in place of first derivative, write its second derivative with respect to d and multiply with one more x, that is with x square. And then put d equal to a, d dash equal to b. This is step number 2, particular integral. And finally, the last term, the complete solution. We can simply denote with as CS. So the complete solution CS is given by Z equal to the complementary function which we have calculated in step number 1 and the particular integral which we have calculated in this step number 2. So this is the procedure. Now to understand this procedure, we will do minimum 2 examples. So let us start with example number 1. Okay. Solve dou cube z by dou x cube, dou cube z by dou x cube minus 3 times dou cube z by dou x square dou y plus 4 times dou cube z by dou y cube is equal to e power x plus 2y. This is the problem. Okay. Now, first of all, express each and every term on the left hand side in terms of the standard notation. So already we know the standard notation. So we know that d dou by dou x stands for d. Dou square by dou x square will be denoted with d square. Okay. Dou cube by dou x cube will be denoted with d cube. Similarly, dou by dou y will be denoted with d dash. Next, dou square by dou y square will be denoted with d dash square. Dou cube by dou y cube will be denoted with d dash cube. Already we had introduced this notation. Next, dou square by dou x dou y. One derived with respect to x partially, one derived with respect to y partially. D dash. Next, dou cube by dou x square dou y. Two derived with respect to x and one derived with respect to y. So two with respect to d. So d square one with respect to d dash. Next, dou cube by dou x dou y square. One derived with respect to x d, two derived with respect to y, d dash square. So this is our notation. So our given differential equation, given partial differential equation is same as in this notation. This can be expressed as dou cube by dou x cube, that is capital D cube. So d cube of z minus 3 times dou cube by dou x square dou y means this. Two derivatives with respect to x and one derivative with respect to y. So d square d dash of z. And third one plus 4 times dou cube by dou y cube means d dash cube operating on z. D dash cube operating on z equal to e power x plus 2y. So on the left hand side there are 3 terms. In the first term d cube is operating on z. The second term minus 3 d square d dash is operating on z. The third term 4 d dash cube is operating on z, yielding e power x plus 2y. See, for the same differential equation, this is one form, this is another form, this is another form. Now, let us start with step number 1. In step number 1, we have to find the complementary function. For that, we need the auxiliary equation. So, as per the procedure, the auxiliary equation is simply replace d with m and d dash with 1. So, m cube minus 3 into m square into d dash 1 plus 4 into d dash cube means 1 cube equal to 0. You replace d with m and d dash with 1. That is a procedure. That means m cube minus 3m square plus 4 equal to 0. So this is a cubic equation. By solving this cubic equation, we will get 3 values for m. You have to note down all the 3 values. But the general procedure of solving a cubic equation is first by trial and error method, we will test for different values of m which satisfies the equation. First, we'll try for m equal to 1. If that does not satisfy the given equation, then we'll try for m equal to minus 1. Then m equal to minus 2, like that. We'll try different values until we get one of the value that satisfies the given equation. But luckily here, for m equal to 1, what happens? 1 minus 3 plus 4, 5. That is not 5 minus 3, 2 not equal to 0. But for m equal to minus 1, clearly it is satisfying. Minus 1 minus 3 plus 4 becomes 0. So that is called trial and error method. For m equal to 1, our LHS, that is m cube minus 3m square plus 4 becomes 1 cube minus 3 into 1 square plus 4. That is 2 not equal to 0. So M equivalent does not satisfy the given equation. For M equal to minus 1, our LHS becomes M cube minus 3M square plus 4. So minus 1 whole cube minus 1 minus 3 into minus 1 square plus 1 into minus 3 plus 4. So this is 0. So M equal minus 1 satisfies the equation. That means M plus 1 is a factor of the polynomial, that M cube minus 3M square plus 4. So for this cubic factor, we identified one factor. Now, what are the remaining factors? To know the remaining factors, just simply divide this M cube minus 3M square plus 4 with this M plus 1. This is an ordinary division. You know the method of long division. So to get M cube, we have to multiply M with M square. So M plus 1 into M square becomes M cube plus M square. M into M square, M cube, 1 into M square, M square. If you subtract this, then we will get minus 3M square minus M square minus 4M square. And this 4 will come down as it is. Now to get minus 4M square, multiply this M with minus 4M. M plus 1 into minus 4M becomes minus 4M square. 1 into minus 4M minus 4M. So if you subtract this plus, it will go. Plus 4M plus 4 will remain. 1 M term, 1 constant term. Now to get 4M, multiply M plus 1 with 4. So M plus 1 into 4 becomes 4M plus 4. If you subtract, then we will get 0. So the other factor of this M cube minus 3M square plus 4 is found to be M square minus 4M plus 4 equal to 0, which implies the auxiliary equation now is M plus 1 into M plus 1 into M square minus 4M plus 4 equal to 0. M square minus 4M plus 4 equal to 0, which implies M plus 1 into M minus 2 whole square equal to 0. So the roots are 1 not repeated and 2 twice repeated. These are the 3 values of M. So 2 is repeated twice and 1 is not repeated twice. So let us take 2 as M1, M2 and 1 as M3. So let us take 2 as both M1 and M2 equal roots and 1 as M3. Then the complementary function as per the procedure which you have learned in video number 1 of unit 2 is corresponding to the twice repeated equal root 2, some function of y plus m1x plus x into some function of y plus again m1x. Because m1, m2 are same. So in place of m2, write m1 again. And since m3 is not repeated, some function f3 of y plus m3x. That means f1 of y plus m1 is 2. So y plus 2x plus x into f2 of y plus m1x again, y plus 2x plus f3 of y plus m3x, y plus 1x. So this is our step number 1. So since this is a cubic equation, the step number 1 is found to be lengthy. Whereas in the examination, if you get a second order equation, then step 1 will be very easy. You will get only quadratic equation as auxiliary equation, and we can get the 2 roots very easily. Since the cubic equation, we must be very careful while finding the roots. The first root must be always calculated by using trial and error method. Okay. Now coming to the step number 2, the particular integral. It is denoted by simply pi. So the particular integral pi is given by the inverse operator of LHS. What is LHS operator? What is LHS operator? D cube minus 3 d square d dash plus 4 d dash cube. Okay, so inverse operator of that means 1 by d cube minus 3 d square d dash plus 4 d dash 2. This is to be operated on the right hand side function, which is e power x plus 2y. Okay, in the given problem, what is the right hand side function? E power x plus 2y. Okay, we have to apply the inverse operator 1 by d cube minus 3 d square d dash plus 4 d dash cube. That is to be operated on e power x plus 2y. Okay, now as per the procedure, we have to replace d with a. Here a is 1. and replace d with b. Here b is 2. So put d equal to a, that is 1, and d dash equal to b, that is 2. Then our particular integral becomes 1 by d cube, 1 cube minus 3 into d square, 1 square, okay, into d dash, that is 2, plus 4 into d dash cube. D dash means 2. 2 cube to be operated on e power x plus 2y. Okay. Simply replace d with a, that is quotient of x1, and d dash with quotient of y, b, that is 2. So wherever d appears, replace that with 1. Wherever d dash appears, replace that with 2. So what we got? 1 by 1 cube 1 minus 3 into 1 square into 3 into 2, 6, plus 4 into 2 cube, 4 into 8, that is 32 of e power x plus 2y. But 32 plus 1 means 33. 33 minus 6 means 27. So we got e power x plus 2y by 27. So clearly 27 is not equal to 0. So our step 2 is completed. If the denominator, after replacing d with 1 and d dash with 2, if we get 0 here, then we have to go for the next case. But luckily here, simply by replacing d with a and d dash with b, that is with d with 1 and d dash with 2, we got a non-zero denominator. So step 2 is over. See, observe carefully. In the examination, in every problem, if the first step is lengthy, then automatically second step will be generally simple. Okay, both the steps will not be lengthy generally. So step 1 is completed and step 2 is completed. So we can declare the complete solution. That is step number 3. So step number 3, the complete solution. The complete solution, simply CS, is given by, so the complete solution is given by Z equal to CF plus PI. That means Z equal to CF. CF means the complementary function calculated in step number 1. Means this entire thing. F1 of y plus 2x plus x into F2 of y plus 2x plus F3 of y plus x. Okay. So F1 of y plus 2x plus x into some other function F2 of y plus 2x plus F3 of y plus x. Okay. Plus particular integral. Just now we have calculated is e power x plus 2y by 27. So this is a relation between x, y, and z involving 3 arbitrary functions. So simply declare where F1, F2 and F3 are some arbitrary functions. Let it clearly mention what is F1, what is F2, what is F3. They are arbitrary functions. Okay. So this is the method of solving a homogeneous linear PDEVC constant question. The right hand side function is exponential. So here the particular integral is obtained very simply. But in every problem, we may not get such simple problems, in particular in calculating particular integral. So we'll consider one more problem in which the particular integral contains 2 or 3 cases, failure cases also. So let us take one more such problem. So solve dou square z by dou x square minus 4 times dou square z by dou x dou y plus 4 times dou square z by dou y square equal to e power 2x plus 1. Using the notation of unit number 1, this problem can also be expressed as r minus 4s plus 4t equal to e power 2x plus 1. In unit number 1, already you know this notation. P stands for dou z by dou x, Q stands for dou z by dou y, R stands for dou square z by dou x square, S stands for dou square z by dou x dou y, and T stands for dou square z by dou y square. Either this or this both are same. But here, in our unit number 2, we will express the given equation in terms of d and d dash notation. Already we know the notation. So in given PDE, given partial differential equation is same as, in place of dou square dou x square, write capital T square. So d square of z minus 4 times dou square by dou x dou y. One derivative with respect to d and one derivative with respect to, one derivative with respect to x, is d, one derivative with respect to d dash of z plus 4 times Dou square dou y square. Mean both the derivatives with respect to y. Mean d dash square operating on z, giving e power 2x plus 1. So on the left hand side, in the first term, d square is operating on z. In the second term, minus 4d d dash is operating on z. In the third term, 4d dash square is operating on z, yielding e power 2x plus y. Yielding e power 2x plus y. This is the given problem. Okay. Now, what is our step 1? We'll write the auxiliary equation by simply replacing d with m and d dash with 1 on the left hand side operator. So in place of d square, you will get m square. In place of 4 d dash, we will get 4 into m into 1. In place of 4 d dash square, we will get 4 into 1 square. So m square minus 4m plus 4 equal to 0. So we will get m square minus 4m plus 4 equal to 0. So this is a quadratic equation. And you can simply solve a quadratic equation. We have to find the factors. But here, luckily, m square minus 4m plus 4 is nothing but m minus 2 whole square. So the factors are m minus 2, m minus 2. So the roots are 2 comma 2. So roots are equal, m1 equal to m2. So we can directly write the complementary function, some function of y plus m1x, y plus 2x. Since m2 is also same as m1, we will write x into some function f2 of y plus 2x. Okay. Already you know the method of writing complementary function. So I am not explaining this in detail because already you know. Now coming to the particular integral. The particular integral is we have to apply the inverse operator of LHS on the right hand side function. What is the operator on the left hand side? D square minus 4d d dash plus 4d dash square. So 1 by d square minus 4d d dash plus 4d dash square. This is to be operated on the right hand side function. What is the right hand side function here? E power 2x plus y. So this is to be applied on e power 2x plus y. Okay. Now, so what is the process? We have to replace d with a, means d with 2, and d dash with b, d dash with 1. Simply put d equal to 2, d dash equal to 1. Then what we will get? 1 by d square means 2 square minus 4 into d, 2 d dash 1 plus 4 into d dash square 1 square. This is to be operated on e power 2x plus 1. But here, if you observe carefully, denominator is 4 minus 8 plus 4. Means we are getting 0. The previous problem, we got the denominator as 27 non-zero. So we have stopped the process of finding particular integral. Already we got the particular integral. But here, we got 0. So we have to mention this as a failure case. Whenever the denominator becomes 0, then we have to treat that as a failure case. Failure case means we have to proceed further to get particular integral. The particular integral is not completed. So as per the process, what we have to do is, so multiply with x, open power brackets, replace the denominator d square minus 4d d dash with 4d dash square, the denominator with its first order partial derivative with respect to d. So dou by dou d of d square minus 4d d dash plus 4d dash square. This is to be operated on e power 2x plus y. Okay. That means x into 1 by partial derivative with respect to d, means we have to treat d as variable and d dash as constant. So what is derivative of d square with respect to d? 2d. And with respect to d, minus 4d dash is a constant into derivative of d1 plus this 4d dash, because this entire thing is constant with respect to d. So plus 0. This is to be operated on e power 2x plus y. Again, same, replace d with the coefficient of x, that is 2, and d dash with the coefficient of y, that is 1. Then we will get x into 1 by 2d. 2 into, what is d? 2. Minus 4 into d dash. What is d dash? 1. To be operated on e power 2x plus y. So again, 2 into 2, 4. 4 minus 4, 0. Still we got 0 only in the denominator. So x into 1 by 0 of e power 2x plus y. That means again a failure case. Again, a failure case means still the particular integral is not arrived. Still we have to continue. So, as per the procedure, what we have to do? So, as per the procedure, we have to multiply with one more x and we have to replace denominator with its second derivative. In place of dou by dou d, we have to write dou square by dou d square. And here outside we have to consider x square. Okay. So, x square into 1 by dou square by dou d square of our d square minus 4d d dash plus 4d dash square. And this is to be operated on the right hand side function e power 2x plus 1. In the denominator, we have second derivative. Second derivative means derivative of the first derivative. Already first derivative is calculated 2d minus 4d dash. Okay, first derivative is already calculated here 2d minus 4d dash. So write that as it is. So for that first derivative, we have to find another derivative. So x square into 1 by derivative of 2d with respect to partially to derivative of 4 dash. There is a constant, so 0 of e power 2x plus 5. So what we got? X square by 2 minus 0 means 2 of e power 2x plus 5. Since 2 is not equal to 0, we got the particular integral, means step 2 is completed. See, observe the difference between previous problem and this problem. The previous problem, by simply replace d with a and d dash with b, we got non-zero. So we have stopped the process there itself. Just observe carefully. But simply by replacing d with, see, in the previous problem, by replacing d with a 1, d dash with 2, we got 27 denominator non-zero. So we have stopped the particular integral straight away here, close. But here, after replacing d with a, that is 2, d dash with b 1, first we got 0 in the denominator. So as per the procedure, we have multiplied outside with x and we have replaced the denominator with its first order partial with respect to d. We got 2d minus 4d dash. Again, we replace d with 2, d dash with 1. Still we got 0. So we have multiplied with one more x. We have replaced denominator with its next derivative, second derivative. But the second derivative of this d square minus 4d d dash plus 4d dash square is derivative of the first derivative, 2d minus 4d dash. And derivative of 2d minus 4d dash is 2. There is no d here, no d dash here. So nothing to substitute. Already this is 2 minus 0 constant, which is non-zero, close. Okay. So we can declare the complete solution. So the complete solution is given by z equal to cf plus pi. Cf means the part of the solution derived in first term. f1 of I plus 2x plus x into f2 of I plus 2x. Complementary function is a part of the solution corresponding to the LHS only. So f1 of y plus 2x plus x into f2 of y plus 2x, that is step 1. And in step 2, we got this x square by 2 into e power 2x plus 1. So this is the complete solution. Now, I advise you to practice one more problem to get clarity. Just I will give the problem, practice and check whether you understand the concept clearly or not. And that problem is, yes, solve dou cube z by dou x cube. So this is for only for practice. You check whether you understood the concept or not. Minus 4 times dou cube z by dou x square dou y. Dou x square dou y minus, plus 5 into dou cube z by dou x dou y square minus 2 times dou cube z by dou y cube equal to e power 2x plus 1. Okay. So practice yourself. So try this problem. If you are able to solve this problem, then you can do any problem of this particular model. Okay. So this is video 2. So in this video, we have calculated, we have discussed the method of finding the homogeneous linear partial differential equation, either of second order or third order, whatever it may be, when the right hand side function is an exponential function e power ax plus by. So this is what we have discussed in this video. So in the next video, we will discuss the method of solving f of d dash of z equal to sin ax plus by or cos ax plus by. Okay. So until then, practice this.